Picture the early 1920s. Victoria's appetite for electricity is growing faster than anyone can supply. Melbourne suburbs are spreading out. Trams are also pushing further out. Factories are multiplying. But the municipal plants that kept the lights on in the 1910s are now straining at the seams. For households and industries alike, power cuts and supply shortages were becoming a daily reality. Enter the newly formed State Electricity Commission of Victoria, led by Sir John Monash. Its job? To bring order, scale, and engineering vision to a chaotic patchwork of power supply infrastructure. The Commission's main bet was brown coal at Morwell, where enormous reserves promised reliable fuel for thermal stations. But Monash and his engineers also looked north, to the rivers running down from the Victorian Alps. The question was simple. Could these mountain streams be harnessed for reliable, renewable power? The first serious investigations were carried out by consulting engineers J.M. and H.E. Coane, under commission from the state. Their task was to identify viable hydroelectric catchments in northeast Victoria. This was not just a matter of surveying rivers. It meant weeks of climbing ridges, measuring flows, calculating elevations, and assessing where the rugged alpine country could realistically support large-scale works. By 1921, they had narrowed the field. The Strathbogie Ranges were investigated but found to be uneconomic, with limited elevation and poor flow. These granite tablelands simply could not provide the vertical drop or sustained volumes required for viable hydrogeneration. The Rubicon and Royston rivers, by contrast, offered steep gradients, consistent alpine rainfall, and proximity to both irrigation storage and transmission corridors. Here was the combination the engineers had been hunting for: geography that naturally lent itself to high-head, Pelton-driven power. At the same time, the Sugarloaf Weir on the Goulburn River, the forerunner of today's Lake Eildon, was already under construction by the State Rivers and Water Supply Commission. Originally conceived purely for irrigation storage, its regulating ability made it a perfect partner for hydro development downstream. The SEC realised that it could piggyback on this project, leveraging the steady water supply into the Goulburn River catchment and smoothing out seasonal fluctuations that had doomed many earlier hydro ideas. By mid-1922, the SEC had a solid plan: a 5-station, high and medium head scheme designed to feed into both Melbourne's electrical grid and further regions of northern Victoria. The stations were modest in size to today's standards, but clever in arrangement, strung like beads down the valley of the Rubicon and its tributaries. This distributed approach meant that the SEC could capture energy at multiple elevation drops, reusing the same water again and again, before finally releasing it back into the Goulburn system. The scheme would eventually comprise the numerous hydro generation facilities which we now know today. The Royston Power Station on the upper Royston River, approximately 300 metres of driving head, a single Pelton wheel unit of roughly 750 kilowatts. It was a compact, high-pressure design, with water delivered through a timber and steel penstock via a small diversion weir. Rubicon Falls Station, located above the junction of the Royston and Rubicon rivers, roughly 120 metres of head, one Pelton wheel of roughly 300 kilowatts, not originally envisioned in the 1922 plans, but later designed and included given its proximity to the other facilities. Rubicon Station, the central hub of the system, with 2 Pelton units at roughly 9.2 megawatts of combined capacity. And also the lower Rubicon Station, downstream of Rubicon Falls and Rubicon Power Station, with roughly 60 metres of driving head, resulting in about 2.7 megawatts of capacity via a single generation unit. By reusing tailwater from each facility, the SEC showed its commitment to extracting every possible kilowatt from these rivers. The Snobs Creek Station, a supplementary plant proposed on a small tributary of the Goulburn east of Rubicon and Royston, roughly 100 metres of head, and about 1.2 megawatts of capacity in total. Though quite similar compared to the other facilities, and knowing that every extra drop would be valuable for balancing demand across the network, it was proposed but never built in the end, Rubicon Falls taking its place. In total, the Rubicon-Royston elements of the scheme proposed about 12 to 13 megawatts of installed capacity, producing an estimated 115 gigawatt hours per annum, with unusually high capacity factors, thanks to careful regulation and integration with the other Sugarloaf storage. But power without a mechanism of delivery is useless, and here the SEC was bold. Transmission lines were planned in two main directions, southwards to Melbourne via Bundoora, tying directly into the growing metropolitan grid, and northwards via Benalla, with feeders to Shepparton and Wangaratta, bringing rural Victoria into the new age of electrification. Voltage was set at 66,000 volts, high for the time, ensuring efficient delivery over the 130-kilometre route to Melbourne. The choice of Pelton wheel turbines was also deliberate. The Rubicon and Royston were steep, narrow rivers, high head, low volume streams that suited Peltons perfectly. The scheme also proposed semi-automatic or unattended operation at the smaller stations, with staff concentrated at the central Rubicon station, cutting down operating costs while maintaining good response times and reliability. Aqueducts were another defining feature. Engineers designed long, concrete-lined channels with tight gradients to convey mountain water to forebays above the stations. Steel or timber penstocks then dropped it 100 or more metres to the Peltons below. In effect, the scheme was a network of carefully balanced civil and mechanical works, tuned to extract every kilowatt from alpine rainfall. Financially, Rubicon Power was not the cheapest. Brown coal at Morwell, with huge seams ready to feed boilers for decades, was hard to beat on a cost per kilowatt hour basis. But Monash and the Commission argued that hydro brought diversity, resilience, and regional reach. It reduced dependence on a single fuel source, and its clean water power was especially attractive in an era where coal transport by rail could be disrupted by strikes, floods, or simple bottlenecks. The 1922 report estimated that £551,000 for generating works and local transmission would be required. It would also need a further £241,000 for transmission to Melbourne and £169,000 for the Northern Transmission Line. In today's terms, this was still a substantial outlay, roughly $98 million in Australian dollars today, but well within the scale of the SEC's mandate to electrify the state. For Monash, the cost was justified not just by how the kilowatts were generated, but by the statement of intent. Victoria was stepping into the modern world of integrated state-run electricity. On July 21st, 1922, Chief Engineer H.R. Harper submitted his detailed report confirming the scheme's technical soundness and refining its economics. Within weeks, Monash and his fellow commissioners presented their introductory report to Parliament, recommending adoption of the Sugarloaf-Rubicon hydro development as a companion to the works at Morwell. It was a decisive moment. Hydropower was never going to carry Victoria alone, but in the Rubicon catchment, Monash and his engineers found a scheme that was technically bold, geographically strategic, and politically sellable. It showed that the SEC wouldn't be a one-trick coal commission, but a diversified energy authority with both thermal and hydro in its arsenal. The Sugarloaf-Rubicon scheme marked the start of Victoria's hydroelectric story. Construction would follow through the 1920s, carving aqueducts into the mountainsides and lowering penstocks down forested slopes. For the workers who followed it, it meant years of earthworks, concreting, and battling alpine weather. But in 1922, it was only a vision. A gamble by a young SEC that the mountain rivers of the state could be tamed into feeding turbines. And it was a gamble they were prepared to take. Tune in for the next episode where, following contracts being signed, Earth began to move. I'm Paul Michael Angus. Thanks for joining me.